Okay. So what is meant by critical radius of insulation? Anyone? Rishikesh. What is the meaning of critical radius of insulation? Sir, class Nara, what is the meaning of critical radius of insulation? Or critical thickness of the insulation? The insulation up to which what will happen? Heat transfer rate will be increases, and after that heat transfer rate will be decreases. Upon the graph काढलेला आठवत असेल. Okay. Up to the peak point, what will happen? Heat transfer rate will be increases, and after that point, what will happen? Heat transfer rate will be decreases. That is nothing but critical thickness of the insulation. So, what are the different applications for this? Steel pipe and steam pipe and electric cable. So, what is the condition for the electric cable? Insulation radius काय असणार आहे? R2 is less than critical radius RC. And what about the steam pipe? R2 is greater than RC. Okay, so all of you get this point, critical radius of insulation. Okay. Now today we have to discuss the next point, that is heat conduction with internal heat generation. So all of you give the new heading as a write down heat conduction with. So in last lecture we have solved the two problems related to the critical radius of insulation. Last lecture आपण काय घेतलेले दोन प्रॉब्लेम सॉल्व केलेले आहेत. ओके, so that point is over. Now we have to see the next point, heat conduction with internal heat generation. मोबाईल मध्ये बघा सगळ्यांना. Okay, write down the next heading as a heat conduction with internal heat generation. Internal heat generation. Okay, so what is the meaning of this internal heat generation? So up till now we have to consider that there is a no internal heat generation. Okay, म्हणजे आतापर्यंत आपण QG is equal to 0 consider करत होतो. Now we have to consider that QG have some value, means some internal heat generation will be there. Okay, so we have to consider that factor. Okay, so what are the examples for that where the heat generation will be takes place? So write down the examples. Fuel rod in the nuclear reactor. So whatever the nuclear reactor is there, okay, fuel rod, nuclear reactor. So in that what will happen? Internal heat generation is there. Okay, so this is the example where the QG having some value is there. Then electrical conductor. Okay, so in electrical conductor also some heat will be generated. Then chemical and combustion processes. So because of the chemical reaction or combustion process, what will happen inside that particular chemicals, what will happen? Some energy will be generated. Okay, so this is the third example. And drying and setting of the concrete. Okay, so in that case also some heat will be generated within that particular component. So these are the examples where the internal heat generation is there. आतापर्यंत आपण काय म्हणतो ते internal heat generation 0 असायची, पण these are the some of the examples where the internal heat generation is there. Okay, so all of you write down some examples where heat conduction and heat generation. Some examples where heat conduction and heat generation is going to takes place. Some examples where heat conduction and heat generation is going to takes place are write down the examples. First one, fuel rod nuclear reactor. Fuel rod nuclear reactor. Second, electrical conductor. Then third, chemical and combustion processes. And last one, drying and setting of concrete. Okay, so now we have to consider the internal heat generation for the derivating the different equations. Okay, so it is of paramount importance that the heat generation rate to be controlled, otherwise equipment may be failed. Okay, so whatever the heat generation within that element, it should be controllable, otherwise what will happen, that component will be failed. Okay, जी काय heat generate होणार आहे ती कशी व्हायला पाहिजे, कंट्रोलेबल असली पाहिजे. Okay, so this is the one of the point. Example, some nuclear accidents, electrical fuses blow out, etc. These are the examples where the uncontrollable heat generation will be takes place. Uncontrollable heat generation असेल तर काय होणार आहे, some accidents will be takes place. Okay, so we have to maintain the heat generation within the element in a controllable manner. Okay, then thus in the design of thermal systems, temperature distribution within the medium and rate of heat dissipation to the surroundings assume ample importance and significance. Okay, so it's a काय आहे तर importance आहे, significance आहे. Okay, so now we have to consider one component, plane wall with uniform heat generation. म्हणजे आपण काय consider करणार आहे, we have to consider one plane wall, and in that particular plane wall what will happen, some internal heat generation will be takes place. Okay, up till now we have not considered that factor. We have considered Qg is equal to 0, but whatever the derivation for the internal heat generation is there, we have to consider Qg having some values there. So according to that, we have to derive the equation. Okay, so write down the new heading, plane wall with uniform heat generation. 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 Draw this diagram. Draw the diagram, plane wall. Okay, so along x-axis what will happen, the length will be changes. Okay, so there are different locations are there, x is equal to 0, then x is equal to L by 2, then x is equal to capital L. Okay, and we have considered one small element having thickness is dx, and the distance from the x y-axis to that particular element, that is x. Okay, then temperature at the left face, that is T1, then temperature at the right face, that is T2. Okay, तर हा जो कर्व ड्रॉ केलेला आहे, व्हॉट एव्हर दी कर्व इज ड्रॉ केलेला आहे, त्याच्यामध्ये काय दाखवलेलं आहे बघा, T1 Tmax आणि T2 दाखवलेला आहे. तर हे आपल्याला डेरिवेशन नंतर समजणार आहे. ओके, where we got the maximum temperature for the plane wall. Okay, so all of you draw this T1, Tmax, T2. One element is there, Qx amount of heat is conducted into the element, and Qx plus dx, that much amount of heat is conducted out from the element. Okay, and total thickness of this element is nothing but capital L along the x-axis. Okay, what are the different parameters of this plane wall? Thickness is capital L. Okay, we have considered one small element, then Qx amount of heat is conducted into the element, and Qx plus dx, that much amount of heat is conducted out from the element, and we have considered that Qg is nothing but internal heat generation. Okay, so whatever this small element we have considered, in that element Qg amount of heat is generated. Okay, and T1 is equal to T2 is equal to Tw, that is the wall temperature. So whatever the wall surfaces are there, we have to consider that temperature as a Tw, wall temperature. It is same, that is T1 is equal to T2 is equal to Tw. हे आपण इक्वेशन डिराइव केल्यानंतर समजेल तुम्हाला हे T1 is equal to T2 काय येत आहे, Tmax कुठे भेटणार आहे. Okay, so after the derivation we get that things where the maximum temperature we get. Okay, so diagram is over. Okay, so write down the things related to that diagram. Consider a plane wall of thickness L. Consider a plane wall of thickness capital L. Okay, we have considered the thickness of that plane wall as a capital L. Consider a plane wall of thickness capital L of uniform thermal conductivity K. What is the thermal conductivity of this plane wall? That is K. Okay, consider a plane wall of thickness capital L of uniform thermal conductivity K. Uniform thermal conductivity K, and in which heat sources are uniformly distributed in the whole volume. Okay, so whatever the volume of that plane wall, we have distributed the heat sources. Okay, आपण काय केलेले आहे त्याच्या आतमध्ये heat sources uniformly distributed केलेले आहेत. So therefore there should be some internal heat generation is there. Okay, so for that purpose we have distributed the heat sources in that particular plane wall. Okay, so write down in which heat sources are uniformly distributed, in which heat sources are uniformly distributed in the whole volume, uniformly distributed in the whole volume, full stop, and the wall surfaces are maintained at temperature T1 and T2. Okay, so this is the plane wall. So whatever the left surface is there, whatever the right surface is there, we have to consider the temperatures as a T1 and T2. Okay, so whatever the left surface is there having temperature is T1, and whatever the right surface is there having temperature is T2. Okay, so these are the parameters related to this plane wall. Okay, thickness is capital L, thermal conductivity is K, and wall surface temperatures are T1 and T2, and we have distributed the heat sources in that particular plane wall so that some heat will be generated within that particular element. Okay, so write down, let us assume that we have to assume the some conditions. So for the deriving this derivation, we have to consider that let us assume that heat flow is one dimensional. Let us assume that heat flow is one dimensional. Let us assume that heat flow is one dimensional, comma, under steady state condition, under steady state conditions, and there is a uniform volumetric heat generation within the wall. Okay, so up till now we have to consider that there is a no internal heat generation, but now we have to assuming that there should be internal heat generation is there. Okay, so therefore we have written that there is a uniform volumetric heat generation within the wall. ओके, म्हणजे त्या एलिमेंट मध्ये काहीतरी हीट काय होणार आहे, जनरेट होणार आहे. आतापर्यंत आपण QG is equal to 0 कन्सिडर करत होतो, बट इन दिस केस वी हैव टू कन्सिडर दैट QG हैव सम वैल्यू. ओके, सो देयर इज ए uniform heat generation within the wall. Okay, full stop. Then write on the next line, consider an element of thickness dx. So we have considered one small element and having thickness is dx. Diagram मध्ये दिसते तुम्हाला. We have considered one small element having thickness is dx at distance x from left hand face of the wall. Okay, तो element जो आहे तो left hand face पासून x एवढ्या distance वरती आहे. Okay, consider an element of thickness dx at distance x from left hand face of the wall, at distance x from left hand face of the wall, left hand face of the wall. Okay, so now we have to calculate the heat conducted into the element. So what is the distance where the heat conduction will be takes place? That is x. Okay, x एवढ्या distance वरून काय होणार आहे, heat conduction होणार आहे. Where the heat conduction will be takes place into that element. So our aim is to write down the equation for the conduction. So what is the standard formula for the conduction? Q is equal to what? Minus K into A into dt by dx. Okay, so here variable also x direction is there. So we have to take the dt by dx. Okay, so write down the equation. Heat conduction in at a distance x. Heat conduction in at a distance x. Heat conduction in at a distance x. So write down the general equation. Qx is equal to Qx is equal to minus k into a into dt by dx. Qx is equal to minus k into a into dt by dx. Equation number 1. Give the name as a equation number 1. Okay. Then heat generation in the element. Okay. So capital Qg is nothing but volume into small qg. Already we have discussed that equation. कशामध्ये बघितलेलं सांगा हे qg's equation, where we have written this equation of qg. Plane wall. आठवतंय का बघा, जनरल हीट कंडक्शन इक्वेशन इन कार्टेशियन कोऑर्डिनेट सिस्टम. Okay, so where we have calculated the value of capital A, capital B and capital C. Okay, so whatever the value of capital B is there, okay, so in that case we have calculated the value of qg. Okay, so in that way we have to write down the equation for the qg. Write down capital qg is equal to volume into small qg, and for this plane wall what is the volume? Area into thickness. Okay, so area is capital A and thickness is dx. Okay, so write down the equation. Capital qg is equal to volume into small qg, and what is the value of volume for this plane wall? Area into thickness. Okay, so area is nothing but capital A and thickness is nothing but dx. Okay, so write down, this is the equation number 2. Capital qg is equal to A into dx into small qg. Okay, so what is the meaning of small qg? Small qg म्हणजे काय असतं? Heat generated per unit volume per unit time of the element. Okay, so from that we have written the equation for the capital qg. Small qg into volume. Okay, so heat conduction in at a distance x, qx is equal to minus k into a into dt by dx. Then heat generation in the element, capital qg is equal to volume into small qg. And for this particular element, what is the volume? Area into dx. Okay, similarly we have to write down the heat conducted out at a distance x plus dx. म्हणजे जो काय एलिमेंट आहे त्याच्यामधून किती हीट कंडक्ट होणार आहे, म्हणजे किती हीट आउट होणार आहे. Okay, so we have written as a qx plus dx. So our aim is to write down the equation for that, qx plus dx. Okay, so write down. Similarly, heat conducted out at a distance x plus dx. Heat conducted out at a distance x plus dx. Okay, so write down that equation. Qx plus dx is equal to qx plus d by dx, qx dx. Heat conducted out at a distance x plus dx is equal to qx plus dx is equal to qx plus d by dx of qx into dx. Already हे इक्वेशन आपण बघितलेलं आहे. कशामध्ये बघितलेलं आहे? जनरल हीट कंडक्शन इक्वेशन इन कार्टेशियन कोऑर्डिनेट सिस्टम. तेच आपण रिपीट करतोय. फक्त आपण इथं काय कन्सिडर करणार आहे? We have to additionally consider as a qg have some values there. In that case we have considered that qg have 0 value. Okay, so write down the equation, energy balance equation for that particular small element. Okay, so how much amount of heat is conducted into the element, that is qx. Okay, some amount of heat is generated within that element, that is qg, and qx plus dx, that much amount of heat is conducted out from the element. Okay, so what is the equation? Energy balance equation. Heat त्याच्यामध्ये किती पाठवली तुम्ही, त्याच्यामधून किती जनरेट झाली, ती सगळी काय होणार आहे? Conduct होणार आहे out of that particular element. So therefore, what is the energy balance equation? Qx plus qg is equal to qx plus dx. So write down energy balance on the element of thickness dx. Energy balance on the element of thickness dx. Energy balance on the element of thickness dx is given by write down that equation. Qx plus qg is equal to qx plus qg is equal to qx plus dx. Okay, so we have written the equation for the each term. We have written the equation of the qx, we have written the equation for the qg. Okay, so we have written the equation for the qx plus dx. Okay, so initially we have to put the value of qx plus dx. Okay, qx plus dx ची व्हॅल्यू काय आहे बघा. We have written this value of qx plus dx, that is equation number 3. So we have to put that value into this equation. Okay, qx plus qg is equal to, what is the value of qx plus dx, that is qx plus d by dx of qx into dx. Okay, so in left hand side qx is there, in right hand side qx is there. So what will happen? That will be cancelled. So write down the remaining equation. Qg is equal to d by dx of qx into dx. Qg is equal to d by dx of qx into dx. Okay, and we have written the equation for the qg. So what is the equation of the qg? Volume into small qg. Okay, so a into dx into small qg is equal to, what is the value of qx? We have written the equation of the qx as a minus k into a into dt by dx. So I have to put the values into this equation. A into dx into qg, a into dx into qg is equal to d by dx of minus k into a into dt by dx into dx is equal to d by dx into bracket minus k into a into dt by dx into dx. Okay, so simplify this equation. A into dx into qg is equal to k, डेरिवेटिव्हच्या बाहेर घेतलेला आहे, into d by dx of minus dt by dx into dx. Okay, so right hand side dx and left hand side dx will be cancelled, then area also cancelled. So what is the remaining? Qg is equal to what? Qg is equal to k into d by dx of minus dt by dx. Okay, so how to take the derivative of derivative? So what is the equation for the derivative of derivative? Derivative square. Okay, so in that form write down the equation. Qg by k is equal to minus d square t upon dx square. Derivative घ्या, derivative घेतलं तर derivative चा square होणार आहे. So it is nothing but minus d square t upon dx square. Okay, Qg by k is equal to minus d square t divided by dx square. Okay, इथेपर्यंत झाले सगळ्यांचं. Okay, then write down this equation. So take the minus d square t upon dx square at the left hand side. So the equation became d square t upon dx square plus qg by k is equal to 0. असे इक्वेशन आपल्याला मिळालेलं का बघा बरं. हे इक्वेशन बघितल्यावर तुम्हाला वाटते का हे इक्वेशन आपण आधी सॉल्व्ह केलेलं आहे? वाटते का सर? कुठं सॉल्व्ह केलेलं आहे सांगा. आपण हीट जनरल हीट कंडक्शन इक्वेशन इन कार्टेशियन कोऑर्डिनेट सिस्टीम बघितलेली आहे. त्याच्यामध्ये वेगवेगळ्या कंडिशन बघितल्या, लॅपलास इक्वेशन, फोरियर इक्वेशन. ओके, हे कशाचं इक्वेशन आहे सांगा. त्याच्यामध्ये आपण बघितलेलं आहे, त्याच्यामध्ये आपण वेगवेगळ्या कंडिशन कन्सिडर केलेल्या होत्या. ओके, if qg is equal to 0, if steady state is there. Okay, so according to that we have written the equation. Okay, so we got the equation as a, so this is a one dimensional steady state heat conduction equation with internal heat generation. Okay, steady state condition असताना आणि internal heat generation असताना अशी पण केस आपण कन्सिडर केली. So at that time we get this same equation. Okay, so d square t upon dx square plus qg by k is equal to 0. This is the one dimensional steady state heat conduction equation with internal heat generation. Okay, all of you get this point. Already we have derived this equation, but in this case we have considered the qg have some value, and we have considering that we have derived the equation, also we get the same equation. Okay, d square t upon dx square plus qg by k is equal to 0. Okay, इथं मी खाली लिहिले बघा. Also from general heat conduction equation in Cartesian coordinate system. आठवतंय का बघा, आपण असं इक्वेशन लिहिलं, dou square t plus qg by k is equal to 1 upon alpha dt by dt. ओके, आणि हे वेक्टर फॉर्म मध्ये आहे. हे जर एक्स वाय झेड च्या कोऑर्डिनेट सिस्टीमच्या फॉर्म मध्ये लिहायचं झालं तर काय येणार आहे? d square t upon dx square plus d square t upon dy square plus d square t upon dz square plus qg by k is equal to 1 upon alpha dt by dt is equal to 0. Okay, so in this equation we have to consider one dimensional heat flow, means what? y आणि z काय होणार आहे? 0 होणार आहे. आता ह्या केस मध्ये आपण काय कन्सिडर केलेलं आहे? We have considered there is a internal heat generation is there. So Qg by K is equal to 0. It is possible? No. So therefore Qg by Q have some value is there. So we have to consider that factor. And if steady state is there, then what about the right hand side? Steady state असेल तर काय म्हणतोय आपण, anything with respect to time, that quantity becomes 0. Okay, and इथे काय, temperature changes with respect to time, so that factor becomes 0. Okay, so by putting this value we get the same equation. आपल्याला परत तेच equation मिळते. Okay, as we have considered steady state heat conduction, so therefore we get the equation as a d square t upon dx square plus qg by k is equal to 0. समजलं, हे फायनल इक्वेशन मिळालेलं आपल्याला. नाउ वी हॅव टू फाइंड आउट दी टेम्परेचर डिस्ट्रीब्यूशन इक्वेशन. इथपर्यंत दिले इक्वेशन ए. ऍक्च्युली काय आहे हे लिहिलं नाही तरी पण चालतंय, कारण आपण परत इक्वेशन ए तेच आहे इक्वेशन, पण ते तुम्हाला सांगितलंय कसं आलंय. आपल्याला आधी पण हे सेमच इक्वेशन मिळालेलं. इन दॅट केस वी हॅव टू कन्सिडर दी whatever the conditions are there, we get the same equation. म्हणजे इथपर्यंत लिहिलं आणि डायरेक्ट जरी तुम्ही इथनं लिहायला चालू केलं तरी सुद्धा चालेल, नो प्रॉब्लेम. ओके, सो राइट डाउन टेम्परेचर डिस्ट्रीब्यूशन इक्वेशन. इक्वेशन ए फक्त द्या याला, d square t upon dx square plus qg by k is equal to 0. that is equation A. Equation A. Now we have to derive the equation for the temperature distribution when there is a internal heat generation. Okay, so write down same equation. We have to write down d square t upon dx square plus qg by k is equal to 0. So this is equation A. So now our aim is to calculate the value of t. So can anyone tell me how to calculate the value of t by using this equation? काय करावं लागेल? काय करावं लागेल? We have to take the integration. Okay, so whatever the equation is there, what is the equation? D square t upon dx square plus qg by k is equal to 0. So we have to take the integration of this equation. By taking the integration, what will happen? One derivative and integration will be cancelled for the first term. So what is the term for that? dt by dx plus what is the integration of qg by k? What is the integration of qg by k? That is x. Okay, so qg by k into x, and constant is there, so equal to constant as a c1. We have to consider constant as a c1. Okay, so our aim is to calculate the value of capital T. So again we have to integrate that particular equation. Okay, so again on integrating, so take again the integration of that particular terms. So integration of dt by dx plus integration of qg by k into x is equal to integration of c1. Integration of c1. Okay, so what is the integration of dt by dx? So as we know that integration and derivative are opposite to each other, so integration and derivative will cancel to each other, so we get the t. Then integration of x, x square by 2. Okay, so qg by k into x square by 2 is equal to integration of c1, that is c1x, plus constant is there, that is c2. Okay, so write down t plus qg by k x square by 2 is equal to c1x plus c2. Okay, so can anyone tell me how to calculate the values of constant c1 and c2? कसे calculate करणार सांगा? Nikita, how to calculate c1 and c2? कसे calculate केले? We have seen the so many equations are there. Okay, for the calculating the values of constant, काय करावं लागतं? C1 value boundary conditions. Okay, it is correct. So from this diagram, can anyone tell me what are the boundary conditions are there? त्या diagram साठी आपल्याला काय करायचं आहे? We have to use the boundary conditions. Okay, so what are the boundary conditions? डायग्राम कडे बघा सगळ्यांनी. Boundary conditions. So at x is equal to 0, what is the value of temperature? Okay, at x is equal to 0, we have considered that left face having temperature is T1 and whatever the right face is there having temperature is T2. So when x is equal to L, then T is equal to T1, and when x is equal to 0, then T is equal to T1. So we have to use these boundary conditions and find out the values of C1 and C2. Okay, so all of you do this. Find out the values of C1 and C2. Okay. Case 1 consider करा. Okay, case 1. That is x is equal to 0. इथे बघा आपण दोन केसेस कन्सिडर करणार आहे. In first case we have to consider that both the surfaces have the same temperature. Okay, means whatever the left surface is there and whatever the right face is there, so we have to consider the same temperature. Okay, so what is our boundary condition? At x is equal to 0, x is equal to 0, then T is equal to T1, and if x is equal to L, then T is equal to T2. But we have to consider the case as a both the surfaces have same temperature. म्हणजे T1 and T2 काय असणार आहे? Same असणार आहे, and we have to consider that temperature as a wall temperature, that is TW. Okay, so at x is equal to 0, T is equal to T1, but we have to considering that both the surfaces have same temperature and that is nothing but TW. So therefore we have to consider T is equal to T1 is equal to TW. Okay, and second boundary condition as a at x is equal to L, T is equal to T2, but we have considered that both the surfaces have same temperature and we have considered as a TW. म्हणजे T1 is equal to T2 is equal to TW असं आपण कन्सिडर केलेलं आहे केस 1 मध्ये. So therefore at x is equal to L, T becomes TW. Okay, T is equal to T2 is equal to TW. Okay, so put these boundary conditions into equation B. So this is our equation B. So in this equation we have to put that two boundary conditions and find out the value of C1 and C2. Find out करा आणि सांगा मला C1 and C2 ची व्हॅल्यू काय आहे त्या. Equation B जे आहे, this is the equation B. So in this equation we have to put these two boundary conditions. First boundary condition is nothing but at x is equal to 0, T is equal to TW, and if x is equal to L, then T is equal to T2 or TW. Okay, so put these boundary conditions. By using first boundary condition, the equation becomes T च्या जागेला काय येणार आहे? TW येणार आहे आणि x च्या जागेला काय येणार आहे? 0 येणार आहे. म्हणजे ही टर्म 0 होईल. is equal to C2 is equal to D TW. Okay, x is equal to 0 असताना T is equal to TW च आहे. x is equal to L असताना पण T is equal to TW च आहे. कारण आपण कंडिशन काय कन्सिडर केलेले आहे? Both the surfaces have same temperature. So therefore x is equal to 0 असो किंवा x is equal to L असो, T becomes TW. Okay, so therefore put that values. So therefore we get the value of C2 is equal to TW. Okay, then apply the second boundary condition and find out the value of C1. Second boundary condition apply kara. Put that values into equation B. Then we get the equation as a TW plus QG by 2K into L square is equal to C1 into L plus C2. Okay, so C2 ची value आपण already calculate केलेली आहे. C2 is nothing but TW. So therefore TW plus QG by 2K into L square is equal to C1L plus TW. Okay, so by QG by 2K into L. Okay, so all of you get this point. What is the value of C1? QG by 2K into L. This is the value of C1. कारण TW cancel होणार आहे. Okay, whatever the left hand side is there, right hand side is there, TW is there, so therefore that term will be cancelled. Which value? C1 and C2. We have to put that values again in that same equation. Okay, so whatever the values of C1 and C2, we have to put that values into equation B. Okay, put C1 and C2 in equation B. All of you get these values of C1 and C2. सगळ्यांना मिळाले का C1 आणि C2 च्या व्हॅल्यूज? ओके, बघा C2 ची व्हॅल्यू TW आणि C1 ची व्हॅल्यू काय Qg/2k into L. Okay, so now we have to put these values C1 and C2 into equation B. Put C1 and C2 in equation B. Put C1 and C2 in equation B. Okay, what is our equation B? T plus Qg/k x square by 2 is equal to C1x plus C2. So in this equation, L is equal to x. Okay, put the values of C1 and C2 in equation B. So we get the equation as a T plus Qg/k into x square by 2 is equal to Qg/2k into L into x plus TW. Okay, so rearrange the terms. So TW have to take in the left hand side. So T minus TW is equal to Qg/2k into L into x minus, so whatever the left hand side term Qg/k into x square by 2. So we have to take at the right hand side. Okay, so minus Qg/k x square by 2. Okay, so T minus TW is equal to Qg/2k. We have to take as a common, so Lx minus x square. Okay, or in simplification form, how to write this equation? T is equal to Qg/2k into bracket L minus x into x plus TW. Okay, so this is the temperature distribution equation. So by using that we can calculate the temperature at any location. समजतंय बघा, ह्या इक्वेशनचा यूज करून कुठल्याही लोकेशनचं तुम्ही टेम्परेचर फाइंड आउट करू शकताय. म्हणजे x ची व्हॅल्यू किती असू द्या, we have to put the value of x in that equation and find out the temperature at any location. Okay, so this is the temperature distribution equation when there is a internal heat generation. म्हणजे एखादा कंपोनेंट आहे त्याच्यामध्ये जर हीट जनरेट होत असेल प्लेन वॉल मधून, तर त्या केस मध्ये आपल्याला हे इक्वेशन यूज करायला लागेल. बाय युजिंग दिस इक्वेशन वी कॅन कॅल्क्युलेट द temperature distribution or temperature at any location. Okay, so next we have to calculate the, in order to determine the location of maximum temperature, काय करावं लागेल सांगा. आपल्याला काय करायचं आहे, ही जी प्लेन वॉल आहे त्याच्यामध्ये मॅक्झिमम टेम्परेचर कुठे असेल हे फाइंड आउट करायचं आहे. आपण काय कन्सिडर केलेलं आहे, Qg amount of heat is generated within that element. Okay, so for this condition कुठल्या लोकेशनला मॅक्झिमम टेम्परेचर असणार आहे हे आपल्याला फाइंड आउट करायचं आहे. सो हाऊ टू फाइंड आउट दॅट व्हॅल्यू? डिफरन्शिएशन घ्यायचं आणि काय करायचं, इक्वेट टू 0. ओके, सो डू दॅट. इन ऑर्डर टू डिटरमाइन द लोकेशन ऑफ मॅक्झिमम टेम्परेचर, in order to determine the location of maximum temperature, determine the location of maximum temperature, differentiate above equation C with respect to x, differentiate above equation with respect to x and equate it to 0 and equate it to 0 and equate it to 0 and equate it to 0. Okay, so what is our equation? T minus TW is equal to Qg/2k into bracket L minus x into x. This is the equation C. Okay, so take the derivative of this and equate that value to the 0. Okay, d by dx of T minus TW is equal to d by dx of Qg/2k into bracket L minus x into x. Equate that value to the 0. ओके, सो व्हॉट इज द डेरिव्हेटिव्ह ऑफ Lx? Lx चं डेरिव्हेटिव्ह काय असणार आहे? L असणार आहे. आणि व्हॉट इज द डेरिव्हेटिव्ह ऑफ x स्क्वेअर? 2x. Okay, so put that values, take the derivation. So what is the derivative of left side? dt by dx minus 0. Okay, इथं असं का आलं असेल सांगा? t minus tw चा आपण डेरिव्हेटिव्ह घेतलेला आहे. We are taking the derivative of t minus tw. Okay, so dt by dx minus 0. Why the derivative of tw is 0? कॉन्स्टंट आहे. वॉलचं टेम्परेचर काय असणार आहे? कॉन्स्टंट असणार आहे. सो टू, आणि हा टेम्परेचर, हा टी जो आहे तो व्हेरिएबल आहे. आपल्याला काय करायचं आहे? कुठल्याही लोकेशनचं टेम्परेचर फाइंड आउट करायचं आहे, म्हणजे तो व्हेरिएबल आहे. वॉलचं टेम्परेचर कसं आहे? फिक्स आहे. ओके, सो टी इज नथिंग बट इट इज अ व्हेरिएबल. So that derivative is nothing but dt by dx, and tw is a constant, so derivative of constant becomes 0. Okay, so write down dt by dx minus 0 is equal to qg by 2k. What is the derivative of Lx? That is L. And what is the derivative of x square? That is minus 2x. Okay, so put that value is equal to 0. So dt by dx is equal to qg by 2k into bracket L minus 2x is equal to 0. Okay, so therefore qg by 2k into bracket L minus 2x is equal to 0. Okay, so our aim is to calculate the location of the maximum temperature. म्हणजे आपल्याला x ची व्हॅल्यू फाइंड आउट करायची आहे. Okay, so write down the equation qg by 2k into bracket L minus 2x is equal to 0. Okay, इथं मला सांगा, एखादी प्लेट आहे and we have considered that in that plane some heat will be generated. म्हणजे qg is equal to 0 असेल का? हीट जनरेट होते म्हणजे qg 0 असेल का? नाही. 2k म्हणजे काय असणार आहे? थर्मल कंडक्टिव्हिटी ऑफ दॅट पर्टिक्युलर एलिमेंट. ती 0 असणार आहे का? नाही. म्हणजे qg by 2k हा फॅक्टर 0 येईल का? नाही ना. म्हणजे हा प्रोडक्ट जो आहे तो 0 आहे. So what is the another meaning of that? L minus 2x become 0. qg by 2k ही जर व्हॅल्यू 0 नसेल आणि प्रोडक्ट जर 0 असेल तर कुठली तरी व्हॅल्यू 0 पाहिजे. म्हणजे कुठली व्हॅल्यू 0 असणार आहे? L minus 2x, that bracket becomes 0. Okay, so in that way we have to write down qg by 2k is not equal to 0. qg by 2k not equal to 0. qg by 2k not equal to 0. So therefore L minus 2x is 0. Okay, qg by 2k is not equal to 0. So therefore we say that L minus 2x, that is 0. Okay, so L minus 2x is equal to 0. So from that equation, what is the value of L? 2x. And what is the value of x? X is equal to L by 2. So what is the meaning of this? X is equal to L by 2. तुम्ही डायग्राम बघा. आता तुम्हाला समजलं असेल की आपण पहिला डायग्राम ड्रॉ करताना असा कर्व ड्रॉ केलेला आहे आणि मॅक्सिमम टेम्परेचर कुठल्या लोकेशनला आपण दाखवलेला आहे? x is equal to L by 2. म्हणजे तो जो कर्व आहे तो डेरिव्हेशन झाल्यानंतर ड्रॉ करायचा, लक्षात ठेवा. समजतंय बघा, हे डेरिव्हेशन झाल्यानंतर आपल्याला समजलंय की कुठल्या लोकेशनला मॅक्सिमम टेम्परेचर आहे. फक्त आपण डायग्राम काढताना ते काढलेलं आहे. मगाशी पण तुम्हाला म्हटलेलं की कर्व कसा आला ते तुम्हाला नंतर सांगतो. Okay, so at what location we get the maximum temperature? At x is equal to L by 2. Okay, so therefore we have draw that particular graph. Okay, so at x is equal to L by 2. X is where? X is equal to L where? This. So both conditions are satisfied ना. X is equal to 0 म्हणजे x ची व्हॅल्यू 0 असताना म्हणजे कुठली फेस असणार आहे? लेफ्ट फेस असणार आहे. ओके, x is equal to L म्हणजे टोटल प्लेन वॉलची थिकनेस आहे ती L. x is equal to L by 2 कुठे असणार आहे? मिडल असणार. So from that we get the value of x. x is equal to करेक्ट आहे ना. x हा व्हेरिएबल आहे. x ची व्हॅल्यू ऍक्सिस ला 0 असणार आहे. एक्स ची व्हॅल्यू वाढत चालली आहे, सेंटरला काय असणार आहे, एक्स इज इक्वल टू एल बाय 2 म्हणजे त्या प्लेन वॉलचा हाफ असणार आहे आणि प्लेन वॉल एवढी कुठे असणार आहे, एक्स इज इक्वल टू एल ला. X is equal to, so from that we say that X is equal to L by 2 ना. ते कन्सेप्ट वेगळा झाला, हे डायग्राम वरून मी सांगतो X is equal to L आणि ते जे इक्वेशन आहे we have to use that equation for the, we have to find out at what location the maximum temperature is there. So for that we have to derive that equation. So from that diagram we say that X is equal to L, and in that don't think in that way. Okay, so we are finding the at what location the temperature is maximum. So for that we have derived that equation. Okay, okay, so what is the value of maximum temperature? आता आपल्याला maximum temperature find out करायचं आहे. So therefore the maximum temperature occurs at X is equal to L by 2. Okay, so and its value is, now we have to find out that value of temperature. जे काय आपल्याला टेम्परेचर भेटणार आहे, मॅक्सिमम टेम्परेचर. सो व्हॉट इज द इक्वेशन फॉर दॅट, वी हॅव टू derive that particular equation. So what is our temperature distribution equation? T minus TW is equal to Qg by 2K into bracket L minus X into X. So in that equation we have to put the value of X is equal to L by 2, so that we get the equation for the maximum temperature. या इक्वेशन मध्ये तुम्हाला काय करावं लागेल, we have to put the value of X is equal to L by 2. So therefore we get the value of maximum temperature. आपल्याला माहिती आहे कुठल्या लोकेशनला मॅक्सिमम टेम्परेचर at X is equal to L by 2. So instead of X we have to put the value of L by 2, so that we get the maximum temperature equation, that is T max. Okay, so in that we have to write down the equation. T becomes T max when at X is equal to L by 2. टेम्परेचर मॅक्सिमम कधी असणार आहे, ज्या वेळेला X is equal to L by 2 असणार आहे. Okay, so write down in that form, T is equal to T max at X is equal to L by 2. T is equal to T max at X is equal to L by 2. So we have to put that value of X into this equation C. Okay, so instead of T, that T becomes T maximum. So T max minus TW is equal to Qg by 2K into bracket L minus, instead of X we can write L by 2 into L by 2. Okay, so simplify this equation, we get the value of T max. So from this simplification we get the equation for the maximum temperature. Okay, आता आपल्याला समजलं की कुठल्या लोकेशनला मॅक्सिमम टेम्परेचर आहे, that is nothing but at X is equal to L. But what is the value of that maximum temperature? Okay, so which equation we can use for the finding the maximum temperature? We have to use this equation. T max is equal to Qg by 2K into L square by 4 plus TW. ह्या इक्वेशनचा यूज करून आपल्याला काय मिळणार आहे, ती पर्टिक्युलर व्हॅल्यू किती आहे ते आपल्याला मिळणार आहे. ओके, सो T max is equal to Qg by 2K into L square by 4 plus TW. Okay, so this is the equation for the maximum temperature for the plane wall with uniform heat generation is there. Okay, final equation काय मिळेल बघा, T max is equal to Qg by 8K into L square plus TW. T max is equal to Qg by 8K into L square plus TW. Okay, so ओके, याचा अर्थ काय झाला मला सांगा, एक प्लेन वॉल आहे, देयर इज अ वन प्लेन वॉल अँड वी गेट द मॅक्सिमम टेम्परेचर ऍट मिडल. ओके, जर एखाद्या प्लेन वॉल मधलं मिडलचं टेम्परेचर जास्त असेल तर याचा अर्थ काय होतोय, हीट ट्रान्सफर कुठून कुठे होईल सांगा, काय होणार आहे, कारण त्या पर्टिक्युलर प्लेन वॉल मध्ये मिडलचं टेम्परेचर जे आहे ते मॅक्सिमम आहे. व्हॉट इज द अनदर मीनिंग ऑफ दिस, काय होणार आहे, आता हीट ट्रान्सफर जी होणार आहे, आपण काय म्हणतो, हीट ट्रान्सफर विल बी टेक्स प्लेस फ्रॉम दी हाय टेम्परेचर टू दी लो टेम्परेचर. ओके, सो ऍज वी नो दॅट द मिडल टेम्परेचर इज हायर, मीन्स व्हॉट, द हीट ट्रान्सफर कुठून कुठे होईल, मिडल टू काय होणार आहे, दोन्ही वॉल ला होणार. समजते का बघा, आता आपल्याला हे इक्वेशन वरून समजलंय की कुठलं टेम्परेचर मॅक्सिमम आहे. मॅक्सिमम टेम्परेचर मिडलला हे समजलंय. म्हणजे हीट ट्रान्सफर आता मिडल पासून कुठे होणार आहे, दोन्ही वॉलच्या सरफेस कडे होणार. आपण आधी काय कन्सिडर केलं, एक्स डायरेक्शन मध्ये हीट ट्रान्सफर व्हायला लागल्या, पण इक्वेशन डिराईव्ह केल्यानंतर आपल्याला काय कळालंय की मॅक्सिमम टेम्परेचर हे सेंटरला आहे. त्यामुळे हीट ट्रान्सफर जी होणार आहे ती सेंटर कडून कुठे होणार आहे, सरफेस कडे होणार आहे. असं का झालंय, बिकॉज ऑफ देयर इज अ इंटरनल हीट जनरेशन. त्या एलिमेंट मध्ये काहीतरी हीट जनरेट होत्या, त्याच्यामुळे काय होतं तर मिडलचं टेम्परेचर मॅक्सिमम भेटतं. and therefore the heat transfer is takes place towards the left face and right face. समजले का? आधी आपण प्लेन वॉल मध्ये असं म्हणत नव्हतो, आपण डायरेक्ट कन्सिडर करत होतो की लेफ्ट साइड कडून राईट साइडला हीट ट्रान्सफर होतं. पण ज्यावेळेला इंटरनल हीट जनरेशन कन्सेप्ट येणार आहे किंवा इंटरनल हीट जनरेशन असणार आहे, at that time we get the maximum temperature at the middle and the heat transfer is takes place from the middle section to the faces. Okay, so got it? समजले का सगळ्यांना? तर त्याच्यावरून आपल्याला इक्वेशन लिहायचं, राईट डाऊन. हीट ट्रान्सफर देन टेक्स प्लेस टुवर्ड्स, heat transfer then takes place towards both the surface. Heat transfer then takes place towards both the surface, and for each surface it is given by, and for each surface it is given by, and for each surface it is given by, and for each surface it is given by. So write down, according to Fourier's law, according to Fourier's law, according to Fourier's law, Q is equal to minus K into dt by dx. Q is equal to minus K into A into dt by dx. ओके, आता हीट ट्रान्सफर कुठे होणार आहे, लेफ्ट सरफेसला आणि राईट सरफेसला होणार आहे. लेफ्ट सरफेसला x इज इक्वल टू काय आहे, 0 आहे, आणि राईट साइडला काय आहे, x इज इक्वल टू l आहे. तर आपल्याला दोन्ही q फाइंड आउट करायचे. ओके, सो वी हैव टू टेक द x इज इक्वल टू 0, कॉमा x इज इक्वल टू l. q इज इक्वल टू माइनस k into a into dt by dx when x is equal to 0 and x is equal to l. ओके, लेफ्ट सरफेसला x 0 आहे, राईट सरफेसला x l आहे. आता आपल्याला माहिती आहे मिडल टू त्या सरफेस कडे हीट काय होणार आहे, ट्रान्सफर होणार. ओके, सो फ्रॉम इक्वेशन डी, डी इक्वेशन कुठलं आहे बघा, माहिती आहे का? सो राइट डाउन dt by dx is equal to qg by 2k into bracket l minus 2x. dt by dx is equal to qg by 2k into bracket l minus 2x. हे ऑलरेडी आपण इक्वेशन डिराइव केलेलं आहे, dt by dx. इथे आहे बघा, dt by dx. इक्वेशन डी वरती लिहिले का बघा तुम्ही, इक्वेशन डी दिला, dt by dx is equal to qg by 2k into bracket l minus 2x. सगळ्यांनी बघा इक्वेशन डी दिले का त्याला, dt by dx is equal to qg by 2k into bracket l minus 2x. Okay, so we have to use that same equation. Okay, so from equation D, dt by dx is equal to qg by 2k into bracket l minus 2x. And what is the equation of the q, minus k into a? So in this equation we have to put that value of dt by dx. Okay, so what is the value of dt by dx? qg by 2k into bracket l minus 2x. The value put करा त्याच्यामध्ये, qg by 2k into bracket l minus 2x at x is equal to 0 and x is equal to l. आता initially we have to calculate at x is equal to 0 what is the value of q. Okay, at x is equal to 0 म्हणजे जे काही इक्वेशन आहे त्याच्यामध्ये काय करावं लागेल तुम्हाला, x ची व्हॅल्यू 0 पुट करावी लागेल. ओके, सो पुट द व्हॅल्यू ऑफ 0 at x is equal to 0. The equation becomes q is equal to minus k into a, q is equal to minus k into a, qg by 2k into bracket l minus 2x. So x value is 0. Okay, so therefore we get the equation as q is equal to minus k into a into qg by 2k into l. When x is equal to 0, we got that equation. इथेपर्यंत झाले सगळ्यांचं. ऍट एक्स इज इक्वल टू 0, that equation is over. At x is equal to 0. Okay, so write down the equation. Q is equal to minus k into a. इथे काय चुकले सांगा या इक्वेशन मध्ये. इन दिस फर्स्ट इक्वेशन इथे x is equal to 0 लिहायला पाहिजे का आता, पण ऑलरेडी आपण x is equal to 0 पुट केलंय, परत लिहायची काही गरज नाही. त्यामुळे डायरेक्ट इक्वेशन लिहा फक्त. Q is equal to minus k into a into qg by 2k into L. Okay, now we have to consider the second condition at x is equal to L. Okay, so put the value of x as a L in the same equation. So what is the equation? Q is equal to minus k into a into bracket qg by 2k into bracket L minus 2. X is there, so instead of x we can put the value of L. Okay, x च्या जागेला L ची value put करा. So we get the equation as a Q is equal to k into a into qg by 2k into L. तो ब्रॅकेटच्या बाहेर x is equal to L लिहिले ती लिहू नका शेवटच्या टर्मला. Q is equal to k into a into qg by 2k into L. तुम्हाला अर्थ समजला का बघा. at x is equal to 0, what is the equation of Q? X is equal to 0 काय इक्वेशन आहे सांगा. minus k into a into qg into L divided by 2k. and what is the equation at x is equal to L? Equation is same, दोन्हीचे इक्वेशन सेम आहे, फक्त साइनचा डिफरन्स आहे. what is the meaning of negative sign? जी काय हीट ट्रान्सफर होणार आहे आपण अलॉंग एक्स ऍक्सिस ला काय कन्सिडर केलेलं आहे, पॉझिटिव्ह कन्सिडर केलेलं आहे, पण ती काय होत आहे मॅक्सिमम टेम्परेचर जिथं आहे तिथून ते कुठे चाललेलं आहे हीट एक लेफ्ट साइडला चाललेलं आहे, म्हणजे निगेटिव्ह ऍक्सिस कडे चाललेलं आहे. सो देअरफॉर द निगेटिव्ह साइन इज देअर. ओके, म्हणजे टोटल हीट ट्रान्सफर किती झाले कसे फाइंड आउट करणार, हाऊ टू कॅल्क्युलेट द टोटल हीट ट्रान्सफर. दोन्हीची तुम्हाला काय करावं लागेल, ऍडिशन करावं लागेल. म्हणजे तिथे निगेटिव्ह साइन तुम्हाला कन्सिडर करायची गरज नाही, दोन्हीची व्हॅल्यू सेम आहे, फक्त एक लेफ्ट साइडला गेले त्यामुळे त्याचं साइन निगेटिव्ह आलाय. ओके, values are same, so therefore how much amount of heat is transferred, how to calculate that, we have to take the addition of that two values. Okay, left face ला किती ट्रान्सफर झाली, राइट फेस ला किती ट्रान्सफर झाली, त्या दोन्हीचे ऍडिशन म्हणजे काय होणार आहे, टोटल हीट ट्रान्सफर. ओके, सो फ्रॉम दॅट वी हॅव टू राइट डाउन टोटल हीट ट्रान्सफर. हेच इक्वेशन लिहिलेलं आहे फक्त. when both surfaces are considered काय होणार आहे, फक्त 2 न मल्टिप्लाय करा, 2 into L into qg by 2. इथे काय झाले बघा, हे जे इक्वेशन आहे फायनल x is equal to L लिहिलेलं, याच्यामध्ये k पण आहे, न्यूमरेटरला पण आहे, डिनॉमिनेटरला पण आहे, त्यामुळे k कॅन्सल झाला. सो व्हॉट इज आवर फायनल इक्वेशन, q is equal to what, q is equal to a into L into qg by 2. इथं पण तसंच होणार आहे, इथला पण के कॅन्सलच होणार आहे. ओके, ते ब्रॅकेट मध्ये असल्यामुळे ते कॅन्सल करायचं राहिलंय तिथं. ओके, सो व्हॉट इज आवर फायनल इक्वेशन फॉर द क्यू, दॅट इज a into L into qg by 2. ओके, सो दिस मच अमाउंट ऑफ हीट इज ट्रान्सफर्ड टुवर्ड्स द राइट सरफेस and this much amount of heat is transferred to the left surface. So we have to take the addition of that two values or we have to multiply by the 2. दोन न मल्टिप्लाय करा किंवा दोन्हीचे ऍडिशन करा, we get the टोटल हीट ट्रान्सफर. म्हणजे ज्यावेळेला दोन्ही सरफेस आपण कन्सिडर करणार आहे त्यावेळेला किती हीट ट्रान्सफर होणार आहे, दॅट वी हॅव रिटन. ओके, सो राइट डाउन when both surfaces are considered, when both surfaces are considered, when both surfaces are considered, q is equal to 2 into a into L into qg by 2. Okay, so 2 will be cancelled. So what is our final equation, a into L into qg, a into L into qg. ओके, समजलं का सगळ्यांना. प्लेन वॉल मध्ये टेम्परेचर कुठे मॅक्सिमम असणार आहे, ऍट दी सेंटर. सेंटर कडून काय होणार आहे, दोन्ही सरफेस कडे हीट ट्रान्सफर होणार आहे. आता जी सरफेस वर हीट आली ती कुठे जाईल सांगा, सराउंडिंगला जाणार आहे. म्हणजे सराउंडिंग म्हणजे काय असणार आहे, एअर असणार आहे. Then which mode of heat transfer is there? Convection. म्हणजे जेवढी काय हीट कंडक्ट झालेली आहे मिडल पासून सरफेस पर्यंत तेवढीच हीट परत कुठे जाणार आहे? सराउंडिंग मध्ये जाणार आहे. ओके, सो दॅट मोड ऑफ हीट ट्रान्सफर इज नथिंग बट convection. So now we have to write down the equation for the convection. Okay, so write down also write down equation संपत नाही लिहा तुम्ही. Also the heat conducted to each wall surface is further dissipated to the surrounding atmosphere. Also the heat conducted to each wall surface is further dissipated to the surrounding atmosphere. Okay, म्हणजे कुठल्या तरी एका फेजची हीट कन्सिडर करा. So Q is equal to AL into QG by 2. That much amount of heat is conducted onto that particular surface. This heat काय होणार आहे? That heat is dissipated into the surrounding due to the convection. So what is the equation for the convection? So we have to equate that equation to that particular heat transfer. Okay. So what is our final equation? A into L into QG by 2 is equal to what is the heat loss due to the convection? HA into delta T. So in that form we have to write down that equation. Surface temperature काय असणार आहे? TW, that is wall temperature. आणि जी काही surrounding air आहे, what is the temperature of surrounding air? That is TA. Okay, so in that form we have to write down the equation of HA delta T. So H into A into TW minus TA. H into A into TW minus TA. ते इक्वेट करा. काय काय कॅन्सल होते बघा. area will be cancelled. So L into QG by 2H into is equal to TW minus TA. Okay, so TW is equal to what is the equation for the TW? L into QG divided by 2 into H plus TA. Okay, so TW म्हणजे काय असणार आहे? Wall's temperature. Okay, so from this equation we get the temperature of the wall. कशाच्या फॉर्म मध्ये मिळणार आहे? In the form of surrounding air temperature. ज्यावेळेला तुम्हाला सराउंडिंग एअर टेम्परेचर दिला असेल आणि वॉलचं टेम्परेचर फाइंड आउट करायचं असेल आणि बाकीचे पॅरामीटर्स तुम्हाला दिले असतील, प्लेन वॉलचा थिकनेस, त्याच्यानंतर इंटरनल हीट जनरेशन किती होणार आहे, हीट ट्रान्सफर कोएफिशिएंट किती आहे. ओके, सो ऍट दॅट टाइम हाऊ टू कॅल्क्युलेट द वॉल टेम्परेचर बाय दिस. त्या वॉलचं टेम्परेचर फाइंड आउट करू शकता. So wall temperature is equal to L into QH plus T. Temperature distribution equation will become
outside.
आता हे वरती सूत्र आपल्याला इक्वेशन मिळालेलं आहे. T is equal to QG by 2K into bracket L minus X into X plus TW. Okay, so instead of TW put that final equation. TW च्या जागेला इक्वेशन पुट करा. एक्झाम मध्ये लक्षात राहणार का? हे असे डेरिव्हेशन आधी ऑफलाईन मध्ये लिहायला लागायचे. तुम्ही ऑनलाईन मध्ये त्यामुळे तुम्हाला काय करणार? विचारतात. हीट ट्रान्सफर 6 मार्क. Critical radius of insulation. ते काय विचारू शकत नाही परत. Okay, so write down the equation. Temperature distribution equation will become, write down T is equal to QG by 2K into bracket L minus X into X plus TW. So TW ची व्हॅल्यू आपण कॅल्क्युलेट केलेली आहे. Put that value of TW. So equation becomes T is equal to QG by 2K into bracket L minus X into X plus L into QG by 2H plus TA. And maximum temperature काय ना सांगा? What is the value of maximum temperature? What is the equation of maximum temperature? Maximum temperature equation baga. So this is the maximum temperature equation. So in this equation we have to put the value of TW. याच्यामध्ये TW ची value put करा. हे झाले का बघा equation? All of you written up to this point? Anyone? Okay. So now we have to write down the equation for the maximum temperature. So write down, and maximum temperature will become, write down T max is equal to, what is our maximum temperature equation? Qg by 8K into L square plus TW. So in this equation, instead of TW, we have to write down that equation. Whatever the value or whatever the equation we got for the TW, so we have to put that value of TW. Okay, so T max is equal to Qg by 8K into L square plus L into Qg by 2H plus TA. Okay, so this is the maximum temperature in the form of ambient air temperature, in the form of convection heat transfer. Okay, how to write this equation? T max is equal to TA plus, so we have to take the Qg as a common. So what is the remaining terms in the equation? L square L by 2H plus L square by 8K. समझ बघा, what is the maximum temperature equation? TA plus Qg into bracket L by 2H plus L square by 8K. Okay, so this is the case 1. आपण case 1 मध्ये काय consider केलं तर both the surfaces have same temperature. पण दोन्ही जे surface consider केले त्याचं temperature वेगवेगळं असेल तर काय करायचं? Okay, so now write down case 2. Both the surfaces of wall have different temperatures. Write down case 2. बघा आपली 20 लेक्चर झाले तर अजून पहिलाच टॉपिक कंप्लीट नाही. Okay, so write down the case 2. Write down both the surfaces of wall have different temperature. Both the surfaces of wall have different temperature. Okay, so in case 1 we have to consider it as a both the surfaces have temperature same, that is TW. But in this case we have to consider both the surfaces of wall have different temperatures. Means left surface having temperature is TW1 and right surface having temperature is TW2. Okay, so at x is equal to 0, TW1 is there, and at x is equal to L, TW2 is there. So draw this diagram. Both the surfaces of wall have different temperature. Both the surfaces of wall have different temperature. So draw this diagram. At x is equal to 0, temperature is TW1, and x is equal to L, temperature is TW2. So draw this diagram. Okay, so write down whatever the equation B is there. आपण सगळा पार्ट रिपीट करणार नाही, त्यातलं फायनल इक्वेशन फक्त घेणार आहे. So write down from equation B. So whatever the equation B is there in case 1, we have to write down that final equation as a T is equal to Qg by K x square by 2 is equal to C1x plus C2. Now we have to apply the boundary conditions. So whatever the condition we have considered, according to that we have to apply the boundary conditions. And what are the boundary conditions? X is equal to 0 असताना टेम्परेचर काय TW1 आहे, आणि x is equal to L असताना टेम्परेचर काय TW2. ओके, So use these boundary conditions and find out the value of C1 and C2. Okay. Boundary conditions is the change होणार आहे. In case 1, what are the boundary conditions are there? X is equal to 0, T is equal to TW, and X is equal to L, then also T is equal to TW. But in this case, if X is equal to 0, then T is equal to TW1, and if X is equal to L, then T is equal to TW2. Okay, so all of you write down. Here the boundary conditions are. Here the boundary conditions are at X is equal to 0, T is equal to TW1. At X is equal to 0, T is equal to TW1, and at X is equal to L, T is equal to TW2. At X is equal to L, T is equal to TW2. Apply the first boundary condition. By putting the first boundary condition, we get the value of constant, that is C2 is equal to TW1. Okay, so first boundary condition, apply first boundary condition in equation B, so we get the value of C2, that is TW1. Then apply the second boundary condition. Apply kara दोन्ही boundary conditions and find out the values of C1 and C2. What is the value of C1? C2 मिळालेला आपल्याला TW1. Then we have to apply the second boundary condition. So by putting the value of second boundary condition, TW2 is equal TW2 plus QG by K into L square by 2 is equal to C1 into L plus C2. Put C2 is equal to TW1. Then equation becomes TW2 plus QG by K L square by 2 is equal to C1 L plus TW1. Okay. So from this equation, what is the value of C1 ची value काय येते बघा. C1L is equal to, write down that equation, TW2 minus TW1 plus QG by K L square by 2, and from that we can calculate the value of C1. C1 ची value काय येते बघा. Okay, so from this simplification we get the value of C1. So what is the value of C1? TW2 minus TW1 divided by L plus QG into L divided by 2K. Okay, so this is the value of C1. So we get the value of C1 and C2. So put that values of C1 and C2 in equation B. Equation B मध्ये put करा. So what is our equation B? T plus QG by K x square by 2 is equal to C1x plus C2. So in this equation we have to put the values of C1 and C2. C1 and C2 ची value put करा. C1 and C2 च्या values put करा. Okay, so put the values of C1 and C2 in equation B. So we get the equation as a T is equal to, final equation la, TW2 minus TW1 by L plus QG by 2K into bracket L minus X into X plus TW1. So this is the temperature distribution equation when the wall surfaces have different temperature is there. Write down the final equation for the temperature distribution when the wall surfaces have different temperature. So what is the equation? So at that time we have to use this equation. T is equal to TW2 minus TW1 divided by L plus QG by 2K into bracket L minus X into X plus TW1. Okay, so this is the temperature distribution equation when both the surfaces have different temperatures. ओके, बाकीच्या कंडिशन्स आपण बघणार नाही. ओके, दिस इज द टेम्परेचर डिस्ट्रीब्यूशन इक्वेशन. ओके, सो दिस इज अबाउट द प्लेन वॉल. हे आपण कशासाठी बघितलेलं आहे? प्लेन वॉल. नाउ वी हॅव टू सी फॉर द cylinder. Okay, so write down cylinder with uniform heat generation. Write down next heading, cylinder with uniform heat generation. Cylinder with uniform heat generation. सगळ्यामध्ये डेरिवेशनच आहे. Extended, second topic is extended surfaces. In that also derivations are there. In radiation also derivations are there. Only one chapter is theoretical, boiling and condensation. All remaining topics are with derivations and problems are there. Objective. Problem पण असतात. पण हे तुम्हाला समजल्याशिवाय काय येत नाही. सगळं डेरिवेशन माहिती पाहिजे. आता मॅक्सिमम टेम्परेचर कसं येते नुसतं सांगितलं तर कळणार नाही, पण डेरिवेशन म्हणून कळते ना कसं येते, असं असतं. ओके, सो गिव्ह द न्यू हेडिंग एज ए सिलेंडर विथ युनिफॉर्म हीट जनरेशन. सिलेंडर विथ युनिफॉर्म हीट जनरेशन. ड्रॉ दिस डायग्राम. फास्ट ड्रॉ करा सगळे, डोंट डिस्कस. ड्रॉ दिस डायग्राम. सिलेंडर विथ युनिफॉर्म हीट जनरेशन. Do it fast so that we can complete this point. Cylinder with uniform heat generation. Cylinder with uniform heat generation. So draw this diagram. So cylinder is there, wall temperature is TW. We have to consider one small element. Okay, Qj amount of heat is generated within that element. Okay, so whatever this small element we have considered having thickness is dr. Okay, and distance r from the center. And at the outside of this cylinder there is a air having heat transfer coefficient as a h, and whatever the air at the outside of this cylinder having temperature is Ta. ओके, तर सिलेंडरची लेंथ म्हणजे बघा इथं आता दोन्ही व्ह्यूज दाखवलेले आहेत. ओके, जो काही सिलेंडर आहे त्याचा टॉप व्ह्यू पण आहे, फ्रंट व्ह्यू पण आहे. लेंथ किती असणार आहे सिलेंडरची? व्हॉट इज द लेंथ ऑफ दिस सिलेंडर? कॅपिटल एल. तुम्ही सेकंड डायग्राम नाही ड्रॉ केली तरी सुद्धा चालते, काय अडचण नाही. सेल्फ लर्निंग आता है कि तुम्हारा सेल्फ लर्निंग? Which subject is there? Which subject is there for self learning? Okay, so which subject we have selected? It's not decided. You know the subjects? Yes. Subject list. Okay, so write down. Diagram is over. Write down. Consider a cylinder rod. Consider a cylinder rod in which. Consider a cylinder rod in which one-dimensional radial conduction is taking place. Consider a cylinder rod in which one-dimensional radial conduction is taking place. Radial conduction is taking place under steady-state conditions. Radial conduction is taking place under steady-state conditions. Under steady-state conditions. Let Balaji, don't discuss. Let write down. R is equal to, capital R is equal to radius of the rod. let capital R is equal to radius of the rod. Radius of the rod. Capital L is nothing but length of the rod. Capital L is nothing but length of the rod. Capital L is nothing but length of the rod. K is nothing but uniform thermal conductivity of the rod. K is nothing but uniform thermal conductivity of the rod. Uniform thermal conductivity of the rod. And then small qg is equal to uniform volumetric heat generation per unit volume per unit time. Small qg is nothing but uniform volumetric heat generation per unit volume per unit time. Uniform volumetric heat generation per unit volume per unit time. Per unit volume per unit time. H is nothing but heat transfer coefficient. Small h is nothing but heat transfer coefficient. Small h is nothing but heat transfer coefficient. Then TA is nothing but ambient temperature. TA is nothing but ambient temperature. TW is nothing but surface temperature. TW is nothing but surface temperature. TW is nothing but surface temperature. Okay, then write down for obtaining the temperature distribution with internal heat generation. आपल्याला काय करायचं आहे, internal heat generation पण consider करायचं आहे. Okay, so for obtaining temperature distribution with internal heat generation, with internal heat generation, with internal heat generation, let us consider one element of thickness dr. Let us consider one element of thickness dr at a distance of r from the center of the rod for obtaining temperature distribution with internal heat generation. With internal heat generation, let us consider one element of thickness dr. Let us consider one element of thickness dr at a distance of r from the center of rod. At a distance of r from the center of rod. Element of thickness dr at a distance of r from the center of rod. Okay, so we are considering one small element of that rod. Rod मतलब अपन काय करणार है, small element consider करणार है. Okay, so heat conducted into that particular element, that is denoted by the QR. Okay, and heat conducted out from that element, that is QR plus dr. आता हे परत सांगायला नको, हे झालेलं आहे already. Okay, QX plus dx. So similarly we can consider the QR plus dr. फक्त इथं काय होणार आहे, त्या एलिमेंट मध्ये काही हीट जनरेट होणार आहे. दॅट फॅक्टर वी हॅव टू ॲडिशनली कन्सिडर. ओके, सो राइट डाउन द इक्वेशंस. द हीट कंडक्टेड इन ॲट अ रेडियस r, the heat conducted in at radius r is given by, the heat conducted in at radius r is given by, in at radius r is given by. So write down the equation. QR is equal to minus K into A into dt by dr. Okay, so here variable is radius. Along radial direction heat transfer takes place. So instead of dt by dx, we have to consider dt by dr. Okay, so heat is conducted in at radius r is given by, write down the equation. QR is equal to minus K into A into dt by dr. QR is equal to minus K into A into dt by dr, equation number 1. And heat conducted out from that particular element, it is denoted by the QR plus dr. तुम्ही डायग्राम मध्ये जरी मेन्शन केलं तरी चालेल. जो काही एलिमेंट आहे त्याच्यामध्ये हीट जी कंडक्ट होणार आहे ती क्यू आर असणार आहे आणि त्या एलिमेंट मधून जी काही हीट बाहेर जाणार आहे दॅट इज नथिंग बट क्यू आर प्लस डी आर. ओके, सो आय नो दॅट व्हॉट इज द इक्वेशन फॉर द क्यू आर प्लस डी आर, that is QR plus D by DR into QR into DR. Write down the equation number 2. QR plus DR is equal to QR plus D by DR into QR into DR. Okay, so this is the equation number 2. Then heat generation. Now we have to consider the heat generation. आपण तीन फॅक्टर कन्सिडर करणार आहे. त्याच्यामध्ये हीट किती कंडक्ट होणार आहे, how much amount of heat is conducted out from the element and how much amount of heat is generated within that element. Okay, so we have written the equation for the QR, we have written the equation for the QR plus DR. Now we have to write down the equation for the heat generation. So we know that what is the equation for the heat generation. Gaikwad, गौरव चालीकर कोण आहे, गौरव कोण आहे, काय नाव तुमचं, गायकवाडच आहे ना, सांगा. हीट जनरेशनचं इक्वेशन काय ना फॉर द सिलेंडर, जनरल इक्वेशन काय असते हीट जनरेशन, काय असते हीट जनरेशन व्हॉल्यूम इंटू आपण काय म्हणतोय स्मॉल क्यूजी. ओके, सो व्हॉट इज द व्हॉल्यूम फॉर द सिलेंडर, सिलेंडरचं व्हॉल्यूम काय असते 2 पाय RL into dr, 2 pi RL into dr जो काही थिकनेस असणार आहे त्या एलिमेंटचा. ओके, सो राइट डाउन कॅपिटल QG is equal to small qg into 2 pi RL into dr. Okay, so 2 pi RL into dr is nothing but volume of that particular element. Okay, so now we have to apply the energy balance equation. So as we know that energy balance equation is nothing but how much amount of heat is conducted into the element plus how much amount of heat is generated within that element is equal to heat conducted out from the element. Okay, so in that form we have to write down the energy balance equation, that is QR plus QG is equal to QR plus DR. Write down the energy balance equation, QR plus QG is equal to QR plus DR. Okay, so in this equation we have to put the value of QR plus DR. So what is the value of QR plus DR, that is QR plus D by DR into QR into DR. So write down the equation. So QR is on the both sides, so QR will be cancelled. So what is the equation for the QG, QG is equal to D by DR into QR into DR. So already we have written the equation for the QR, already we have written the equation for the QG, so we have to put that values into this equation. QR ची व्हॅल्यू आपण लिहिलेली आहे, QG ची व्हॅल्यू लिहिलेली आहे, so we have to put that values into this equation. So what is the value of capital QG, that is small qg into 2 pi RL into dr, and what is the value of QR, that is minus k into a into dt by dr. So we have to put that values into this equation. Simplify kara equation, simplify the equations. Qg into 2 pi RL into dr minus k into d by dr into 2 pi RL into dt by dr. Area काय असणार आहे सिलेंडरचा 2 pi RL. So instead of n, instead of a, we can write the 2 pi RL. Okay, into dt by dr into dr. Okay, so in the left hand side Qg into 2 pi RL into dr is equal to minus k. So we have to take the outside the bracket, that is constant 2 pi L into d by dr into r into dt by dr into dr. Okay, so 2 pi L will be cancelled. So in the left hand side, what is the remaining? Qg into r, dr is on the both sides, so dr also cancelled. So what is the remaining equation? Qg into r is equal to minus k into d by dr into r into dt by dr. All of you write down this equation. Qg into r is equal to minus k into d by dr into r into dt by dr. Already we have written the equations for the QR plus DR and QG. Okay. Then we have written the energy balance equation, that is QR plus QG is equal to QR plus DR. We have put the values into this equation and we get the equation as a QG into R is equal to minus K into D by DR into R into dt by dr. Okay. So how to write this equation? Again, we have to simplify this equation. So that equation becomes QG R divided by K. हा जो K आहे तो लेफ्ट साइडला घेतलेला आहे. So QG into R by K plus D by dr into R into dt by dr is equal to 0. This is the equation A. Okay. So from this equation, our aim is to calculate the temperature distribution. तर काय करावं लागेल इथे सांगा. Equation A, whatever the equation A is there. So from that equation, our aim is to calculate the equation for the temperature distribution. So how to calculate the equation for the temperature distribution? From this equation A, we have to integrate that equation. So whatever the terms are there, which is related to the derivative. So we have to taking the integration, then automatically derivative terms will be cancelled. Okay. So write down, in order to calculate temperature distribution equation, in order to calculate temperature distribution equation, in order to calculate temperature distribution equation, we have to integrate above equation A twice. In order to calculate temperature distribution equation, we have to integrate above equation twice. Okay, दोनदा integration घ्या. Take the integration 2 times. So integration of QG by K into R plus integration of D by dr into R into dt by dr is equal to 0. So by taking the integration, what is the integration of R? Suyog was ना Sachin पूर्ण सरनेम का Sachin Wagmore. सांगा, what is the integration of R square by 2. Okay, so therefore QG by K into R square by 2 plus, then integration and derivative are opposite to each other, so that becomes cancelled. So plus R into dt by dr is equal to constant, that is C1. Again we have to take the integration. So what is the integration of? पहिल्यांदा divided by R केलेला आहे. पहिला divide करा, then we have to take the okay. So what is our equation? QG by K into R square by 2 plus R into dt by dr is equal to C1, then divided by R to this equation. So therefore equation becomes QG by K into R by 2 plus R will be cancelled, that is dt by dr is equal to C1 by R. Then we have to multiply dr throughout. जे काही equation आहे त्याला dr ने multiply करा. Then what is the equation? QG by K R by 2 into dr plus dt is equal to C1 by R into dr. dr ने काय केलेलं आहे आपण multiply केलेलं आहे both side ला. Multiply by the dr. So QG by K into R by 2 into dr plus dt. dr काय होणार आहे तिथे cancel होणार आहे in the second term. And in the right hand side, we have to multiply by the dr. C1 by R into dr. Then we have to take the integration. Okay, after that we have to take the integration. Okay, so integration of dt plus integration of this QG by K into R by 2 into dr is equal to integration of C1 by R into dr. C1 by R into dr. Okay, so what is the integration of dt, Balaji? Integration of dt, t. Then integration of R into dr, R square by 2, and integration of 1 by R. इंटिग्रेशन काय असते LNR असते का -1/r असते मला सांगा डेरिव्हेटिव्ह ऑफ 1/r काय असते -1/r² आणि इंटिग्रेशन ऑफ 1/r log ऑफ ओके लॉग नाही ln असते ना ln लॉग आणि ln मध्ये डिफरन्स आहे माहिती आहे ना लॉग मध्ये बेस 10 असते आणि ln मध्ये बेस e असते ओके सो राइट डाउन integration of dt is nothing but t then integration of r is nothing but r²/2 so the term becomes qg by k r²/4 is equal to c1 l1 r plus c2 so from that we get the equation for the t as a minus qg by k r²/4 plus c1 ln r plus c2 this is the equation b ओके इथपर्यंत दिले इक्वेशन बी पर्यंत राहिलेलं नंतर घेऊया कंडिशन 1 कंडिशन 2 मॅक्सिमम याच्यामध्ये पण आपल्याला लोकेशन फाइंड आउट करायचं वेअर द मॅक्सिमम टेम्परेचर इज देयर ओके सो इन दॅट वे सिमिलरली व्हॉट एव्हर द कॅल्क्युलेशन वी हॅव टू डू फॉर द प्लेन वॉल इन द सेम मॅनर वी हॅव टू डू फॉर द सिलेंडर okay so remaining part we have to discuss in the tomorrow's lecture okay so thank you very much those who are present online put your roll numbers in the chat box $27, $70, $42 माझ्याकडे रोल नंबर ऋषिकेश 66 45 57 65 5 34 32 19 58 55 48 70 17 okay next 36 24 56 30 okay so those who are present put your roll numbers anyone is remaining Yeah.